Every day, people unlock their phones without thinking twice, but inside that sleek device is one of the most complex machines ever built. It all begins in a place buzzing with energy: Noida, India. Not just any city, this is where Samsung runs the biggest phone factory on the planet. Imagine walking into a space that spans over 129,000 square meters. That's more than 18 football fields laid side by side. The air hums with the synchronized rhythm of machines and humans working in harmony. This factory doesn't just make phones for India, it makes them for the world. Over 120 million of them every single year. Noida isn't just building devices, it's a symbol. It's where Make in India meets Make for the World. When the facility was inaugurated in 2018, India's Prime Minister himself flagged off the vision. Since then, this place has become the global brain of Samsung's mobile manufacturing, contributing nearly 25% of Samsung's global phone output. It all starts with a brain, and by brain, think of the motherboard. This isn't just a slab of silicon, it's a multi-layered marvel. It begins with a bare PCB, a blank canvas, but within seconds, robots buzz to life, placing thousands of components, resistors, capacitors, chips with astonishing speed and pinpoint accuracy. Each SMT machine is a beast in itself, capable of placing over 3,000 tiny components in the time it takes to blink. The process feels like watching a futuristic ballet. Paste is applied with surgical precision, components are mounted, and then the board goes through a nitrogen oven. This massive furnace slowly bakes the layers, ensuring every component is fused just right. Then the board flips. The same steps repeat on the other side. Every tiny part has a job and nothing goes to waste. The alignment needs to be so perfect that even a 1-degree deviation can break the entire circuit. These machines operate under strict temperature control because even a small thermal shift could warp a connection. The paste used to attach components is carefully formulated to withstand heat and vibration. When the board exits the oven, it's inspected again, not by eyes, but by AI-powered cameras that never miss a detail. Optical systems scan for micro cracks invisible to the human eye. It's here that a decision is made, pass or fail, within milliseconds. Boards that don't pass are automatically routed to a diagnostic station where specialists determine the flaw. Meanwhile, flawless boards move forward, advancing like VIPs to the next stage. It's easy to forget that each of these boards is the beginning of a smartphone that might soon power someone's life. That board might end up in a school child's first phone, or a traveler's GPS, or a business owner's lifeline. Each one starts here, under the robotic arms and infrared lights designed to be tough but built with elegance. Even the sequence of the components, where each resistor, each capacitor is placed, is optimized to reduce power loss and increase efficiency. This isn't just about making phones fast, it's about making them better every time. What's wild is that every SMT line operates differently based on the phone model it's producing. One line might be working on a flagship, while another is assembling an entry-level device. The software driving each SMT machine is constantly updated, often remotely, by engineers monitoring performance trends in real time. This digital nervous system connects every corner of the factory, from ovens to optical scanners, from conveyors to cloud dashboards. It's smart manufacturing on a scale that's hard to imagine. Maintenance teams walk the floor, checking calibration, ensuring no nozzle is misaligned, no feed tray runs empty. At any moment, alerts can notify the floor team if a placement is even slightly off-center. Every machine has backup systems, every line has fail-safes. It's a fortress of accuracy. What happens in this SMT stage affects the entire life of the phone. A perfect board means fewer issues down the line, better battery life, better performance, and better user satisfaction. And because these machines are pushing limits daily, there's always a team of software and hardware engineers on standby, fine-tuning algorithms that guide these microscopic placements. The precision isn't just mechanical, it's emotional. There's pride built into every layer, pride that this factory in India is setting the bar for global production. Here, technology isn't just built, it's elevated, but it doesn't stop there. Inspection stations dot the production line using optical recognition and AI to catch the tiniest defects. These aren't just checks, they're safeguards. And after passing inspection, the motherboard transforms into a fully operational PCBA. It's ready for action. With the brain built, it's time to give the phone its face. The screen, sleek, fragile, and essential. To fuse the OLED and glass without a speck of dust getting in, the process takes place in vacuum chambers. Here, the environment is as sterile as a surgical room. Every bubble is eliminated. Every alignment is perfect. The slightest speck of dust can ruin the entire display. That's how delicate and demanding this phase is. And once the screen is ready, the next stage is where automation hits overdrive. Robotic arms place the screen onto the frame, sealing it in a way that no human could. The display isn't just slapped on. It's pressed at precise angles, especially for curved edges seen in flagship models. These tiny components are what allow screens to dim, calls to mute, and faces to unlock phones instantly. Each sensor is checked as soon as it's connected. Batteries slide into position next, sealed carefully, because safety is everything at this stage. No shortcuts, no assumptions. Throughout this process, phones keep moving, never stopping for long. Overhead screens track progress in real time, showing which unit is where and how long it's been there. If a delay happens, systems respond immediately. Another line compensates, another robot steps in. The rhythm never breaks. What stands out most here is balance. Humans and machines share the space without conflict. Robots handle repetition and precision. Humans bring judgment and adaptability. Together, they make sure every phone leaving this line feels exactly the way it should in someone's hand. By the end of this stage, the phone isn't just assembled, it's alive. The screen lights up, the system boots. A device that started as raw materials is now something ready to connect, capture, and communicate. And yet, even now, it's not done. The toughest challenges are still ahead, and the tests begin. There's the airtightness check. Not once, but multiple times. Instead of water, air pressure is used to simulate waterproofing. Fail the test, the unit gets pulled out, disassembled, and diagnosed. Only the flawless continue. But the real thrill, the drop test chamber. Some call it the torture room. Robots drop phones from all angles, on concrete, on metal, on glass, up to 100 times. It's brutal, it's necessary. The goal? Ensure that the screen doesn't shatter and the internals don't get knocked loose. And then function testing takes over. Robots simulate real-world use. Scrolling, tapping, typing, shooting videos, making calls. AI tracks power consumption, app performance, antenna signal strength, and more. There's even a special robot that doom scrolls TikTok all day long, testing battery drain under realistic scenarios. Nearby, rows of phones are tested in a fully automated microwave lab. These chambers test signal reception and transmission under conditions that mimic real-world usage, including body interference. Robots adjust phones to millimeter precision, ensuring every test is exact. Behind the scenes, data pours into terminals that engineers use to tweak future models. In another lab, engineers are testing materials, how glass reacts to UV rays, how hinges survive millions of folds, how polymers wear over time. Machines simulate years of use in hours. These stress tests are what make foldables durable and phones last longer. This level of precision ensures the phone works flawlessly under any condition. It's fascinating to see how every component has a role, no matter how small. Every stage of production is tuned like an orchestra, where machines and humans work in perfect harmony. Samsung's commitment to quality isn't just a slogan, it's built into every layer of the phone. From microscopic resistors to the glowing OLED screen, each part is a testament to engineering brilliance. The factory is alive not with chaos, but with rhythm, a carefully timed dance of technology. Robots aren't just assembling. They're thinking, learning, improving every cycle. In a single day, thousands of phones pass through these lines, each one a marvel of manufacturing. Behind every smartphone is a story of effort, innovation, and relentless testing. This isn't just production, it's perfection at scale. Every product is tracked, logged, and scanned dozens of times before it ever reaches a store shelf. This level of consistency is why phones from this facility are trusted by millions around the globe. All of this is supported by India's own research muscle. Samsung operates multiple R&D centers here, staffed by young engineers developing AI features that power the latest Galaxy devices. These teams contribute to everything from voice recognition to camera algorithms. It's not just manufacturing, it's innovation born and tested in India. And while Samsung's Galaxy AI-powered phones are assembled here, the factory doesn't stop at mobiles. Tablets and even premium AI appliances like refrigerators are also built under the same roof. It's a connected ecosystem built with precision and shipped across continents. This is the stage where all the hard work finally becomes visible. What once looked like scattered parts now starts to resemble something familiar. Frames glide in on conveyors, perfectly timed, never rushing, never waiting. The motherboard settles into place like it was always meant to be there. Cooling paste is applied in precise amounts, just enough to keep performance stable without wasting a drop. Every screw is tightened with calibrated force because too loose or too tight can change everything. Cameras are installed next, and this isn't just about plugging something in. Alignment here is critical. Even a fraction of a millimeter can affect focus, clarity, and image stabilization. Machines guide the placement, but humans supervise closely, watching for anything that feels off. Speakers are tested the moment they're seated, sending quick pulses of sound to confirm clarity and balance. If something doesn't sound right, the phone doesn't move forward, sensors are layered in quietly, almost invisibly. These tiny components are what allow screens to dim, calls to mute, and faces to unlock phones instantly. Each sensor is checked as soon as it's connected. Batteries slide into position next, sealed carefully, because safety is everything at this stage. No shortcuts, no assumptions. Throughout this process, phones keep moving, never stopping for long. Overhead screens track progress in real time, showing which unit is where and how long it's been there. If a delay happens, systems respond immediately, another line compensates, another robot steps in, the rhythm never breaks. What stands out most here is balance. Humans and machines share the space without conflict. Robots handle repetition and precision. Humans bring judgment and adaptability. Together, they make sure every phone leaving this line feels exactly the way it should in someone's hand. By the end of this stage, the phone isn't just assembled, it's alive. The screen lights up, the system boots. A device that started as raw materials is now something ready to connect, capture, and communicate. And yet, even now, it's not done. The toughest challenges are still ahead. The entire process is a showcase of synergy. Humans and machines, design and durability, software and hardware, all coming together to build devices that billions use every day. And after the testing and inspections are done, the final step begins. Packaging. The factory hums as mini robots carry finished boxes, routing them to shipping lines. What started as a tiny PCB has now become a fully functional smartphone, ready to go global. The Noida factory isn't just big, it's smart, strategic, and a sign of how far India has come in tech manufacturing. With 120 million phones produced annually, this is more than a plant. It's a powerhouse. A symbol of vision, execution, and innovation. Enjoyed the deep dive into the biggest smartphone factory in the world? Like, share, and subscribe for more cutting-edge tech journeys.